Hello and welcome. We're all constantly navigating a world that's just full of signals, sounds, signs, different situations that guide what we do next. Today, we're going to break down the science behind all these signals, really exploring the psychological traffic lights that direct our behavior. So let's start with a really simple question that we all know the answer to, but maybe not the why behind it. Why exactly does a green light signal you to press the gas, while a red light makes you hit the brakes? Well, the answer lies in a core concept of behavior analysis. So, here's our plan for this explainer. We'll start by defining what these behavioral traffic lights are. Then we'll get into the specifics of the go and stop signals. We'll look at how we learn when to act and also at our automatic reflexive triggers. We'll tie it all together with a pretty neat doorbell analogy and then finish up with the key takeaways. All right, let's dive right in. The answer to that traffic light question is a phenomenon called stimulus control. And it's really the invisible framework that explains how our environment guides so many of our actions. So what is stimulus control? Put simply, it's when a specific cue in the environment makes a particular behavior more likely to happen. And why? Because over time, we've learned that that specific cue signals that a reward, or reinforcement, is available for that action. Now, the stimulus doesn't force the behavior. It just, it sets the stage for it. To really get this, we need to meet the two main players in this process. You can think of them as the go and stop signals that we encounter all day, every day. Let's break them down. First up, we have the discriminative stimulus, or SD for short. This is your go signal. It's a cue from the environment that tells you reinforcement is probably available for a specific behavior if you do it right now. It's basically the green light. On the flip side, we have the S delta. This is your stop signal. It indicates that reinforcement is not currently available for that behavior. It's your red light, telling you that doing that action right now probably won't pay off. This slide lays out the contrast perfectly. The green light, our SD, makes a behavior more likely because it signals reinforcement is available. The red light, the S delta, does the exact opposite. And this distinction, right here, is pretty much the foundation of learned behavior. Okay, let's see how this builds. These SDs and S deltas are really at the heart of what we call operant stimulus control, and this applies to all the voluntary behaviors we learn through their consequences. The framework for this whole process is the classic three-term contingency: antecedent, behavior, and consequence. You might know it as the ABC model. The antecedent, in this case the SD, sets the occasion for the behavior. The behavior happens, and then it's followed by a reinforcing consequence. It's this link that gives the SD all its power. And as you can see here, these things are happening all around us, every day. Your phone rings, that's the SD, so you answer it. The microwave beeps, another SD, and you open the door to get your food. A teacher says, "Line up," that's the SD, and the kids line up because it signals that recess is coming. These are all learned voluntary actions that are under stimulus control. We see this constantly in applied settings too. A picture of hand washing on a visual schedule, that's the SD for a child to go wash their hands. A break card can become the SD for a student to appropriately ask for a break. The key takeaway here is that the SD just makes that desired behavior more probable. But that's only half of this story. Stimulus control also applies to our automatic reflexive behaviors. This side of things is known as respondent control, and it works a little bit differently. So respondent control is all about pairing. It starts with a neutral stimulus, something that doesn't really mean anything to you. That neutral stimulus then gets repeatedly paired with an unconditioned stimulus. That's something that naturally causes a reflex. Over time, what was once neutral becomes a conditioned stimulus, and it becomes capable of triggering that reflex all on its own. The classic example, of course, is Pavlov's dog. A bell, which was at first just a neutral sound, got paired with food, which naturally causes salivation. After this happened enough times, just the sound of the bell was enough to elicit salivation. The bell, now a conditioned stimulus, had gained stimulus control over an automatic physiological response. So we have these two types of control: operant for voluntary actions and respondent for our automatic reflexes. So can they happen at the same time? Oh, absolutely. And a simple doorbell analogy shows us exactly how. First, let's look at this through an operant lens. The doorbell rings, that's our SD. The dog barks, that's the learned, voluntary behavior. And this behavior has been reinforced in the past by a person showing up at the door. So in this case,
The doorbell occasions the voluntary act of barking. Notice that word I used, occasions.
Okay, but at the exact same time, something else is going on. The sound of that doorbell has also been paired with the natural, reflexive excitement of a visitor's arrival. So now, the sound itself automatically elicits a physiological response, like a faster heartbeat. The doorbell sound has become a conditioned stimulus that triggers a totally involuntary reflex. So there you have it. One sound, two types of control.
So as we start to wrap this up, let's really make sure we've got the most important points down. What are the crucial things you should remember from all of this?
First, let's just clear up a few common misconceptions. Stimulus control doesn't mean a behavior is guaranteed to happen. It just means it's much more likely. Second, not every single cue is an SD. It has to have a learning history of signaling reinforcement. And finally, remember that these signals aren't just words. They can be anything we perceive, like sounds, sights, or even smells.
And here's a simple way to remember the key players. Just think of the SD as the signal for do it, and the S delta as the signal to, well, don't. It's a pretty effective way to keep them straight.
And that leaves us with one final question to think about. What are the discriminative stimuli and the S deltas, the traffic lights, that are guiding your behavior every single day? Because once you understand this framework, you really start to see it everywhere. Thanks for watching.